Thanks very much, Joe. Good afternoon, everyone. Thanks for hanging around to the Arvo. Uh, as Joe said, I'm Taylor. I'm a geologist that works for Euro Corporation. And I'm pretty stoked to be here today to be presenting this on behalf of Andre Koffer and myself and the rest of the Euro team. So before I'd start, I'd just like to thank and acknowledge the traditional owners, not just on the land we're here the next couple of days, but also the people of the land that Euro has worked on all over the Northern Territory, and pay respects to their elders past, present, and emerging. So today I'm going to take you through just a little bit of an overview of the last 2 years of Wilson's find. It's our copper, tungsten, and base metal prospect in the Northern Territory. I'm just going to share some of our initial exploration efforts, along with the first set of drilling results that we got back literally a couple of days ago. So bear with, they're pretty raw. This epic photo here was taken by Andre Koffer, who's sitting in the front over here. He went under the first recce in late October 2022 in a helicopter. And this is flying over Wilson's Find. And you can see here, these are the historic trenches and veins that we are targeting. So it's a really cool shot. Uh, just a quick couple of dot points here to make sure that nothing I accidentally say today gets Andre or the other directors sued. So this is our small team. Who are we? So we are Euro Corporation. We were founded in 2021 by the three directors you see at the top there. Take advantage of demanding critical minerals and energy transition metals. Since our first field trip late in 2022, we've conducted another 14 field campaigns over 23 tenements, sampled over 8,000 surface samples, all which we have PXRF'd in-house, and sent 1,200 of these to the lab for assay. We've done two geophysical surveys in two different commodity classes, drilled and acquired drilled two different programs now, AC and RC drilling program, and have a third one hopefully planned for later in this year. I think what's remarkable is that with the size of this team, we've been able to do all of this by spending less than $2.3 million. It's been a lot of hard work with everyone in the team. It's been really exciting to be a part of. So where are we? I guess before we get stuck into Wilson's Find, I just wanted to point out um, where you are in the Northern Territory. So we've got a bunch of relatively underexplored areas in a variety of different geological settings. We've got our chilling tenements, which are up here, up near Darwin, closer to Litchfield National Park, exploring for lithium in that bino pegmatite field. We've got some uranium as well as sediment-hosted lead zinc. We've got our Charlie Creek projects, which are just closer to Alice Springs on the Tanami along here. We've got some uranium exploration, got some hard rock rare earth potential, along with some base metals. And then we've also got this one prospect over here in Western Australia, which is still pending, but something we're super excited about. It's a really big magnetic anomaly that has not been explored to date. And once that hopefully gets granted, we're pretty keen to get some work out there. And then we've got our sort of west of Runta area, and this is where I'll talk to today, Wilson's Find, but this also includes our beryllium prospect, and then our ionic clay rare earths as well. So it's about 380 kilometres here up the Tanami, and this is where the focus will be of today's talk. Quick intro to Wilson's Find. So what is it and where is it? As I said, it's about 380 k's northwest of Alice Springs. It's a copper, tungsten, and polymetallic veins, which are hosted within the Wabaldali granite. It's been known about for a very long time. Historical mining in the 1940s was targeting tungsten ores, and you can see here in the aerial I've just outlined as well, these are the old trenches which were trenched along the vein orientation here. And they produced about 2 tons of tungsten concentrate back then, but weren't looking at all for the copper or any of the other base metals. There's been plenty of exploration over the years, but it's yet to be drilled. And so this is something that Euro's been really excited about the last couple of years is sort of progressing the exploration efforts, conducting the first geophysical surveys and also drilling. Just quickly, the target geology. So it's hosted within the Wabaldali granite, which you can see in the top map here. It's these little pink polygons through here. So it's only expressed at the surface by sort of minor tores and small outcrop. But in the interpreter map, you can see here that in the bottom, this is the larger extent of the Wabble granite, so 35 by 10 kilometers, um, which for us just sort of opens up a lot more prospectivity potential. 2017 joint geocon project with the NTGS dated the Wabble granite at 1586 million years. Um, this also approximates the maximum and probably true age for the tungsten copper mineralization, which is hosted in these more sort of vein pegmatite phases. Um, Below is just a bit of a conceptual schematic model that we've put together of what we think the system looks like currently. You've got really steeply dipping mineralized veins within the Wabble granite here in green, which at the surface look kind of exactly like that image. You've got really nice big quartz veins that are mapped sort of roughly every 50 meters at surface and range anywhere between 30 centimeters to 2 meters in thickness. Sort of hypothesis is that because we believe these were formed during same time as granite formation, we had magnetic structural hydrothermal processes within the Wabble granite, and then sort of tectonic fracturing potentially created pathways for more of this metal-bearing hydrothermal fluids, which are rich in not just copper, tungsten, but um, the base metals that were concentrated in the veins at shallower depth. So what we're seeing on the surface of this is a more oxidized zone of sort of malachite azurite and cuprotungstite, but we believe that these veins, and what we've been hoping is that the mineralization extends as more sulfides at depth. So what's been our approach? I guess over the last couple of years, we have taken an approach of getting our feet on the ground first and foremost. So we have done 4 separate field campaigns. Um, Started off with some mapping, sampling, gamma ray survey, which we conducted, and then of this PXRF in-house of all the samples and further stuff we have sent to the lab. We then did an induced polarization survey with ZONJ. This led to the planning of our 8-hole RC drill program, which we finally got done in late October last year. Collected 8 tons of drill samples, which has just been analysed. The samples were stuck out due to weather for quite a few months, so we finally got them back and sent them to the lab, and those results are just coming in now. So step 1 was our mapping. We set up a bit of a remote camp out there for 4 days back in April, directly after Aegis last year. As part of this sampling and mapping, we actually also did 150 line kilometers of gamma ray spectrometry, which we did because past surface samples we collected had been quite rich in uranium as well, where there were veins. So this sort of indicated elevated uranium levels in the veins compared to the surrounding granite, making it a pretty useful tool in mapping just below the subsurface and helping us decide where to sample as well. So in this process, and you can see here, some of these blue lines here are the original trenches, but we actually mapped and extended these veins to areas where they hadn't been trenched. We mapped 8 more veins in total, another 1.5 kilometers of lateral extent. All the veins themselves are quartz veins, which is typically dip very steep to the southwest at about 70 degrees. And on the surface, you're seeing, as I mentioned, more oxidized zone of copper tungsten mineralization, mostly malachite azurite, bit of chrysocolla, wolframite, and cuprotungstite. Some of the results, we had some really great results at surface, obviously some which we're expecting that were quite close to their previously mapped veins and trenches, but also in some of the veins that we had mapped further on in extension. So they had copper mineralization, mostly in copper oxides, with the occasional mapped sulfide. Tungsten mineralization was in the form of cuprotungstite, which is this sort of bright yellow one over here, which to be honest was a new mineral for me at the time. And we also had this really cool chunk of tungsten that we found actually that was dug up on one of the drill pads, which was almost all wolframite, 27.5% in tungsten. On top of this as well, we get some really good elevated lead, zinc, uranium concentrations and beryllium as well, sort of suggesting that it really is a polymetallic system. So the next step for Euro, I guess, after considerable ground sampling and mapping, was to conduct a geophysical survey to help with drill targeting. So in June last year, we had Zon's Geophysics, who are here today, so shout out to Zon, conduct a 6 kilometre squared gradient IP survey, which you can see here. The aim of the survey was to sort of assess sulfide mineralization both laterally and vertically, as we knew we were targeting sulfides and chargeability. And the first thing we got from it was this two really nice sort of northwest, southeast trending anomalies. One more to be expected, where we already knew we had veins outcropping at the surface, but another one over here as well to the west, which hasn't been targeted yet, but we believe might just be slightly more buried. And whilst we're doing the survey, the follow up was that we also got two dipole-dipole lines. You can see here in black, which we decided based off areas we already had surface veins mapped, but also areas where we had some really nice chargeability anomalies in the gradient survey. This was the outcome of the IP survey. So what these basically suggest was that the depth coverage for starters was about 200 meters, so not super deep, but gave us confidence to at least that level. And what this survey confirmed to us was that in areas where we had known map mineralized veins, which are not marked on there, but here, for example, and here as well, which is where we'd already mapped these veins, it did correlate with the chargeability anomalies at depth, although not super deep. It still gave us a really good sort of foresight into targeting these drill holes and inform the planning of drilling. We also got this nice anomaly here, which was, not something we knew based on the surface stuff, that became one of the drill targets. So the RC drill campaign, this was really exciting for us, and I think a lot of people, because Wilson's Find, as I mentioned, had been something that people had mentioned that had been wanted to be drilled for a lot of years, and we finally got the opportunity to do that. We were also lucky enough to be awarded one of the Resourcing the Territory drilling grants for this, which really, really aided in sort of us hoping to do a 5-hole pilot program to being able to drill 8 holes, which is fantastic. Bullion Drilling did this drill program for us, and they were absolutely fantastic. So shout out to Bullion as well. The objective of this was to evaluate the depth extent of the copper tungsten mineralization, which we've been seeing in the surface. These targets we identified based on our surface mapping, but also the IP geophysical survey, which we had conducted. So the strategy itself was to focus on perpendicular vein intersection. So knowing that these veins were dipping 70 degrees to the southwest, we wanted to intersect them perpendicular and try and intersect multiple veins in one drill hole. So we angled these holes and then drilled up to about 300 meters, or until we were pretty confident mineralization had been fully tested. 8 holes in total, 2,228 meters, and the depth of the holes range between about 210 to 300 meters. So some of the holes you can see targeted, these are the two dipole-dipole lines. Some targeted these anomalies. Some of the holes just targeted where we had really good surface mineralization in the veins, and some are a bit of a combination of the both. So what the plan was with the drilling intersections in the IP, as I mentioned, was just to target these anomalies at depth via drilling and hopefully intersect some mineralized veins where the actual IP anomalies and chargeability anomalies were. Outcomes that we successfully did intersect through these IP anomalies and hit veins where we actually intersected them. Apologies, this is not the new assay data, as we only got it in a couple of days ago, but this sort of shows we had some logging intersected veins where some of these really good IP anomalies were. And where we intersected the anomalies, we had some good grades of copper and tungsten. We also proved we had mineralization in all of the holes over multiple zones. So some of the initial assay results, as I said, they only came in a couple of days ago, but we're already pretty stoked with some of them. We have sampled to date only 300 of the assays out of a possible 2,229 meters. We did multi-element fire assay results, And so far, we've had promising mineralization in all 8 holes in multiple zones. What I've got up here is just a um, quick cross section of hole 8, which had some of the more significant hits. So I've just got copper and ppm on here. These nice pink zones here are just anything over 1000 ppm. So in hole 8, we had 5 different high grade zones up to about 5 meters thick. 4,000 or 0.4% copper at depth as well, which kind of proved that we weren't just getting mineralization in this oxidized zone, but actually seeing it in sulfides at depth. zero point 0.5 tungsten, and also some quite decent beryllium grades, which is good. Some of the other highlights we had were up to 1% copper in one of the other holes in a 4 meter anomaly, 3000 ppm tungsten, and 2000 ppm zinc. Some good moly, and also 15 grams per ton silver. So we're getting a lot of other metals, and as I said, it suggests that this probably is some good polymetallic mineralization. Also with some good uranium results in there too. So it is all very fresh, as I mentioned, but what are some of the initial interpretations? Well, based on our mapping, we know that we've extended the original extent of the surface mineralization by quite a bit. We've mapped a whole set of new veins with some mineralization at the surface, so there's still a lot more unexplored area there. The IP survey identified chargeability anomalies at depth and a long trend of these veins, which was great. The drilling confirmed these IP anomalies and that these mineralized veins are present at depth and not just a supergene enrichment. And these really preliminary assay results show that we had up to 5 meter intervals of anomalous copper, tungsten, zinc, moly, beryllium in a number of different locations and at various depths. So what's next? Look, we're really excited for the next steps. There's obviously a lot to think about with these results being so fresh. Um, we need to do quite a lot of analysis on these new lab results and integrate these and update our current thoughts on the mineralization and the models. We want to assess the continuity of these structures between drill holes using the geophysics and drilling data, so sort of do more calibration with the IP. This would potentially lead to, more sort of first pass exploration resource calculations. And then what we potentially want to do as well is get some more dipole lines, as we've only got 2 currently across the anomalies, and they prove to be a really good tool in targeting. And then hopefully the plan would be to do some more follow-up RC drilling and potentially diamond drilling further down the line. Um, just some acknowledgements before we finish up. So you're very grateful to the Northern Territory government, especially for the resource and their territory grant. As I said, this is a project that we've been excited about since Andre and the team first picked it up. And to be able to actually drill it and get that money from the government was huge. So thank you. So I want to say also, Andre and myself want to really thank the Euro team. Their hard work and dedication over these past few years has been amazing for such a small team. Our directors are the ones that are out there on the field on their dirt bikes and collecting these samples. So it's really good to see. Also grateful to Mount Dorian Station, Sam and Lil. They've been awesome with land access and their hospitality. And hopefully there will be when we're going to be going out there on Thursday again. And then also a huge thank you to Wayne Taylor, who's here, and Dave Nelson, and our tenement neighbours from GSW and Energy Metals for all their generous assistance and valuable insights over the years. There with. Um, and just quickly, I know that was a very rapid rapid overview. Thank you. Of the work we've done the last couple of years at Wilson's Fire, and it's still only early days. I want to say a huge thank you to the NTGS for allowing Euro the honour to present some of our work up here. Also for everyone listening and staying awake this afternoon. It's my first time presenting a conference like this as well, so it really genuinely means a lot that we were asked to do this. So thanks very much, and thanks for listening.